Hey pre-calc students, welcome to today's first final exam review on Unit 4. We're going to spend a couple of days reviewing what we did in Unit 4 because it was a pretty long unit. Quick reminder, if you haven't retaken a test this semester, you can retake one. And if you, after watching some of these videos and reviewing this unit, feel free to reach out to me if you want to retake this test. Okay, so in these boxes are a couple of really important things we discussed when we first started the unit. So when we first began the unit, we talked about how sine, when you're dealing with right triangles, okay, the sine is opposite over hypotenuse, and its reciprocal is cosecant, which is hypotenuse over opposite. Then we've got cosine and secant, those are reciprocals, and then tangent and cotangent, okay? Now, what we started to do after we started reviewing right triangles, we started graphing angles in degree and radian mode on the coordinate plane on an x and y axis. So we talked about how on the x and y axis, or in a coordinate plane, cosine is represented by, or sorry, x represents cosine, and y represents sine, okay? When you're looking at what quadrant an angle lands in, you got to remember that x is cosine and y is sine. Now remember, there are specific values of positives and negatives depending on what quadrant the angle lies in, so I put these here just to help you remember. When you're dealing with cosine and sine as your x and your y values, you can find tangent by doing y over x, and feel free to add this in. Cotangent would be x over y or cosine over sine. Okay, instead of memorizing the whole unit circle, I had you guys focus on two triangles. So the first one is a 30, 60, 90. Notice that across from the 30 degrees is a 1, across from 60 is root 3, and across from the 90 is a 2. In a 45, 45, 90, the side lengths are 1, 1, and the hypotenuse is root 2. We also talked about how besides degree mode, you had to be familiar with radians. So radians are the ones that are written with pi. Quick reminder that pi over 3 is not 30 degrees. The 3's don't go together. So pi over 3 is 60, pi over 6 is 30, pi over 4 is 45, and pi over 2 is 90. Now, when we started graphing these angles on a coordinate plane, sometimes the angles landed on a quadrant and sometimes they didn't. Sometimes they landed in between quadrants, which are called quadrantal angles. So for the quadrantal angles, we can't use SOHCAHTOA because you can't build a triangle from quadrantal angles. So we use the ordered pairs that came with them. Okay, so just a quick reminder that all those ordered pairs are going to use ones and zeros or negative ones and zeros. All right, so let's talk about these first two examples. They're asking you in which quadrant is the angle located. So they're going to give you just enough information to figure that out. All right, so just think back to what we talked about over here. I'm going to circle this just so you guys know. This is what we're going to be using for this, okay? The fact that x and y values have their own unique signs, positive or negative, depending on what quadrant it's in. All right, so you kind of have to translate the clues to help you. The first clue is that sine is greater than 0. When something is greater than 0, that means it is positive. Who is sine related to? Remember, we're talking about quadrants, so you got to think x and y values. Is sine related to x or y? Sine is related to y. So we're looking for a y value that is positive. Okay. The next piece of information tells me that the tangent of the angle is less than 0. So that means the tangent is negative. Now here's the thing. Who is tangent related to, x or y? Technically, it's related to both. So tangent of an angle is y over x. So what they're saying that this fraction has a value that is negative. Well, we already know the y value is positive. So what sign does the x value have to have so that the whole fraction is negative? Well, positive divided by positive isn't going to give me a negative answer. I want positive over negative. So this means that if my y value is positive, but y over x is negative, then my x has to be negative. So think of your quadrants, right? We got plus, 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 minus. Okay? Oops, I just realized I wrote this one wrong. Super sad. Okay, so remember these represent the x and the y. Oh, Lord of Jesus. Boop. It's one of those days already. Okay, so remember I'm using the signs from here, okay? When you go left from the y-axis, the x values are negative. When you go to the right, the x values are positive. Above the x-axis, y values are positive. Or sorry, above the x-axis, y values are positive, and below the x-axis, the y values are negative. All right, so according to the clues, if the y value is positive, then it can't be anything below the x-axis. If the x value is negative, right, which was, it came from here, which means x value is negative. That means we're left with quadrant 2. So quadrant 2 is the correct answer. Okay, let's try another one. So secant of theta is greater than 0. So what that means is that secant is positive. Well, who is secant related to? Is it related to the x value or the y value? Well, secant is the reciprocal of cosine, and cosine is an x value. So if the cosine is positive, then, sorry, if the secant is positive, then the cosine is also positive. Okay, secant is related to cosine. Now, remember, cosine is related to x, so that means x is positive. So this is all kind of like a chain of events, that the clue gives you. So we're looking for which quadrants cosine is positive, right? So you can already kind of start your process of elimination. X is only positive in quadrants 1 and 4. Now this next piece of information says the sign is greater than 0. So sign is positive, which means, remember, sign is related to the y value. So the y value is positive. And the only place that the y value is positive is quadrant 1. So Q1 is the correct answer for number 2. All right, remember that I'm only going to do some of these problems. The rest are up to you. Okay, so give number 3 a try by yourselves, and we'll check the answers next time I see you. All right, one of the vocab words that was really important in this chapter was reference angle. Okay, so reference angle has a couple of rules. Okay, so in order to be a reference angle, it has to be acute, which means less than 90. It's always to the x-axis, and it must always be positive. Okay, so I'm going to do number 5 because it's a negative angle. So those actually go clockwise. So I'm going to show you how to do those. All right, so here's how we started. We looked at the denominator. So the angle given to you is negative 13 pi over 8. So the denominator tells you how many pieces to cut the top half and the bottom half of the x-axis. Okay, so you're thinking kind of like of a circle here. We're going to cut the top half into 8 pieces and the bottom half into 8 pieces. Okay, so think of a pizza. All right, so for the even numbers, I always use the y-axis as a helper for helping me break it up. Again, the denominator is 8, so that's why we're cutting it into 8 parts for the bottom and the top. Since this angle is negative, we're going to go down and around to graph it. So I'm going to start here as 0. Half of a circle is 8 pi over 8 because that always reduces to 1 pi. So half of a circle is 1 pi. Full circle, so if I were to go full circle, that would be 2 pi, which in this case would be 16 pi over 8, right? Because if you double 8 pi over 8, you get 16 pi over 8. Okay? All right, so now I'm going to go ahead and cut the top half and the bottom half into 8 pieces. Now, just so you know, remember we're going clockwise, okay? Sorry if I said counterclockwise earlier. So we're going clockwise, and 13 pi over 8 is going to be past 8 pi over 8. So you don't really have to waste time cutting the bottom half into 8 equal pieces. Really, you can just focus on, and really you should be kind of drawing all these from the origin, okay? All right, so here's 8 pi over 8. This would be 9 pi over 8, 10 pi over 8, right? Keep going, 11, 12, and then 13 pi over 8 would be here. So let me put negatives on these. Okay, so it's going to land here. So here is the angle, and the reference angle is the shortest distance from the terminal side, so from the arrow where it lands on the angle, to the x-axis. So if I measure from this arrow back to 8 pi over 8, that's 5 spaces, okay? But if I measure from the arrow to the x-axis and count towards the right, that's only 3 spaces. So you always want the smaller distance. So the reference angle here would be 3 pi over 8. And that's the answer. So reference angle, we always used to put like a little apostrophe on it, is 3 pi over 8. Remember that your reference angle is always to the x-axis, must be acute, so it's got to be less than 90, and it has to be positive because it's measuring distance. Distance can never be negative. Okay, another vocab word that we talked about was coterminal. So coterminal means that it lands in the same exact spot as the original given angle. So I'm going to do number 7, and then you guys do number 6 on your own. So for coterminal angles, we had a formula. You had to add or subtract 2 pi. Okay? So notice all of these are in angles, or sorry, are angles in radian mode. If they had given you degrees, then you would add or subtract 360. So we notice that they ask us for 1 positive and 1 negative. Okay? So we're allowed to add or subtract 2 pi until we get what we need. So negative 15 pi over 4 is a fraction. Okay? If I'm going to add or subtract 2 pi to that, then I need to convert that 2 pi into a fraction that has a denominator of 4. Okay, because it has to match the denominator given. Okay, so I can't just add 2 pi to 15 pi over 4. They need to be like fractions. So right now it's 2 pi over 1. I need it to be a 4, so I'm going to multiply the top and bottom by 4. And that gives me 8 pi over 4. So essentially you just double the denominator, and that's the equivalent of 2 pi. Okay? All right, so now I'm going to take the angle, negative 15 pi over 4, and I'm going to add. So they ask for a positive. So if you are, think about it, if you are starting at a negative value, right? Negative 15 pi over 4, let's just say it's here, and you want a positive, then you want to go this way, right? So you get a positive. So when you go to the right, you want to add to get a bigger value, a positive value. So I'm going to go ahead and add 8 pi over 4. Remember, they have to be like fractions. That's why I converted 2 pi to have a denominator of 4. All right, so negative 15 pi plus 8 pi over 4 is something over 4, right? So negative 15 plus 8 is negative 7 pi over 4. So I've actually found a negative coterminal. I'm trying to find a positive coterminal, but by accident I found a negative coterminal. What I'm going to do now is I'm going to take that negative 7 pi over 4 and I'm going to keep adding 8 pi over 4 until I get a positive answer. Okay? So originally when I added 8 pi over 4 to negative 15 pi over 4, I was hoping to get a positive, but it wasn't enough. So then you just got to keep adding 2 pi over 4 till you get a positive. So negative 7 pi over 4 plus 8 pi over 4 is 1 pi over 4, and that is a positive coterminal. So I have found a positive and a negative. Now, if you don't have a positive answer, then you just keep adding 2 pi, right? Or 8 pi over 4 in this case. If you don't have a negative yet, you can subtract 8 pi over 4. So you get a negative. So again, add or subtract 2 pi till you get what you need. All right, so these next few were a huge main focus, and we spent many days on these types of problems. It says find the exact value of the expression. Again, quick reminder, this is no calculator. This whole section is no calculator. All right, so I'm going to do, let's see, I'll do 9 and 11 to kind of help refresh your memory. All right, so take a look at number 9. So they're asking for the secant of negative pi over 6. So what we did first is we just wrote ourselves a little note that secant is asking you for the reciprocal of cosine. So instead of adjacent over hypotenuse, we want hypotenuse over adjacent. Okay? So we want hypotenuse over adjacent. And actually, I think when we learned this, I would write it over here. Secant is hypotenuse over adjacent. All right, so you just need two things to be able to figure this out. You need the reference angle for negative pi over 6. And for these, pretty much whatever the denominator was, that was your reference angle. Okay, so your reference angle is pi over 6. Because it's negative, it's going to be in quadrant 1. So it's negative 1 pi over 6. So you're going to go like this. Boop. Negative 1 pi over 6. And then you draw a 90-degree angle to the x-axis. Because the reference angle is pi over 6, okay, that is a 30-degree. Across from the 30 is always a 1. That means this is 60, so that's root 3. And then the hypotenuse is 2. Just quick reminders that some of these values are negative. So anytime you go down or left, your values are negative. Okay, and now I'm going to find hypotenuse over adjacent. So hypotenuse is 2. Adjacent is root 3. And I'm going to rationalize, so my final answer is going to be 2 root 3 over 3. So just as I'm not going to do 8 and 10, but remember what I said, that the denominator is like your reference angle. You just got to figure out what quadrant it lands in. So like 1 pi over 3 is a positive angle. That's going to be in quadrant 1. But 5 pi over 4, so as you start to think of 5 pi over 4, here's 0, here's 4 pi over 4. Right? 5 pi over 4 is going to actually land in this quadrant. Okay? So just be careful. You got to pay attention to what quadrant it lands in. Now, in 11, we have a quadrantal angle. So they actually didn't give us an angle that has a reference angle that is acute, because 2 pi is actually on the x-axis. So quick reminder, this is 0. This is pi over 290. 1 pi is 180. 3 pi over 2 is 270. And a full circle is 2 pi. That's 360. Okay? So they're asking me for the tangent of 2 pi. Well, again, that angle lands right here. Okay? For quadrantal angles, you can't do your typical SOHCAHTOA stuff. So I can't do opposite over adjacent because there's no triangle possible. So then you're going to use the ordered pair. So the ordered pair here is 1, 0. Remember that the x value is cosine and the y value is sine. So tangent, obviously, you guys know it as opposite over adjacent, but we could also write it as y over x. Remember we talked about that up here. Tangent is also y over x. So if I take the y value of my ordered pair, which is 0, and divide it by the x value, which is 1, 0 divided by 1, is that 0 or undefined? It's 0. All right, guys, as always, if you want extra help, feel free to reach out. Good luck, and we'll see you soon.